To all of you joining me for this video, I am Mr. Ish. Thank you for joining me. I want to spend a few minutes here just to go over this particular question with you all. Minus 1 to 1 dx divided by square root 1 minus x squared. It's a very interesting question, and I will explain to you all why that is the case. When you're looking at this integral, your integrand is this 1 divided by square root 1 minus x squared. That right there is a function. If you were to look at it in terms of a 0, in place of x, your y value is 1, that's a y-intercept. If you were to do the 0 of the denominator, you have vertical asymptotes, x is equal to plus and minus 1. And now if you were to graph it, you're having something like this. Minus 1 plus 1, a y-intercept, and it would be something like this. When you're looking at it in terms of the integral minus 1 to 1, you're looking at now this entire area, the area below the curve, but the area will go along the asymptote and will go up in the direction of positive infinity. If you were to look at this function here at minus 1 and 1 in terms of limit as x approaches this minus 1, but from the right, your function will shoot up in the direction of positive infinity, and it does that. Now when you look at this vertical asymptote, limit as x approaches 1, but from the left, your function shoots up in the direction of positive infinity again. For this particular function here, because of the asymptotes which are involved, you end up seeing a discontinuous integrand, meaning you're looking at something like this, minus 1 to 1. Minus 1 and 1 are not represented as this. They're not part of your domain. They're outside of your domain. And that is why this question here is looking at a type 2 improper integral, where the infinite discontinuities, two of them, are on both sides of this function at the vertical asymptote. That's what you have. That right there is why this is a very interesting question with a very surprising outcome. You would normally expect this to be divergent, but it ends up being convergent. This entire area shows a finite representation. When you're looking at this, if you are thinking about inverse sine x and you do its derivative, you get 1 over square root of 1 minus x squared. Therefore, if you work backwards, it tells you you're looking here at an antiderivative, which is your arc sine or inverse sine. You don't need to do trigonometric substitution the long route. You can avoid all that just by thinking about this. From positive 1 upper limit to minus 1 lower limit, you will do the definite procedure here. You do this on your calculator. Inverse sine of 1 is a pi over 2. Inverse sine of minus 1 is a minus pi over 2. These add up and you get a positive pi. And that represents a very finite convergent outcome for a type 2 integral, which has infinite discontinuities involved. And normally you would expect to see divergence, but surprisingly you see convergence, and that's why I find this particular question very interesting. That's about all I want to show you in this video. Thank you for watching.